In this video, I'm going to show how you can solve compound inequalities, specifically the AND compound inequalities. And there's two ways you can actually solve the AND inequality. Either method works. I'm going to show you both, and then you can use the one that works best for you. The first one I'm going to call just the AND method, and the reason I call it this is because when we solve it this way, we actually split up the compound inequality into two separate inequalities and write the word AND between them. So let's go ahead and get started. So the way we would split it up is if we look at this left side, if I look at just this part of my original problem, if I ignore this less than 10 here, this would be my first inequality. -4 is less than t plus 6. Now I would write the word and now if I look at the right half of it here, and if I ignore the -4 and less than, I would get this inequality, which says t plus 6 is less than 10. Now I have my two separate inequalities for me to solve. For the inequality on the left, I would subtract 6 from both sides. So I would get -10. So my answer would be -10 is less than t. And on the right side again, I would subtract 6, except this time I would get 4. So I would get t is less than 4. So for my graph, for my answer, I have -10 is less than t and t is less than 4. Well, I can write this as one compound statement. So t must be greater than -10 but less than 4. Therefore, -10 is less than t, which is less than 4. Notice I can take what I have here and just put it together. This says t is greater than -10, which says it here, and t must be less than 4. So now let's go ahead and graph our inequality. Now, since I have to include -10 and 4 on here, it might be a good idea to not go by ones. Instead, let's try going by, say, twos instead. That might be a little easier. Now, when I graph this, an AND compound inequality looks like a segment. Okay, so if I say, let's go -12, -10, -8, -6, -4, -2, 0, 2, 4, 6. Now, t is between, it's bounded by -10 and 4, and since it's a less than in both cases and it's not equal to, I'm going to have open circles at -10 and +4, and then I'm going to connect them. T is trapped between these two. It's bounded by -10 and 4, and that's it. So let's do this again over here, except this time, instead of using the AND method, I'm just going to directly solve it. Okay, so let me rewrite the problem here, because we will need a little bit of space. Now, when we directly solve a compound inequality, we have to think of it as an equation, but with two equal signs here. So whatever I do, I'm going to start from the middle and work my way out. So we're used to saying, okay, whatever I do to one side, I do to the other. Well, if you notice, I have three sides now. So if I look at my original problem here in the middle, I want to add 2. Of course, to itself, but notice I have this side on the right and this side on the left, so I have to add it to all three sides. So now my new problem is -6 is less than k, which is less than or equal to 7. Notice it's already in this compound form that we got over on the left side, similar to the one on the left. So in this case, k is trapped between -6 and 7. So we can go by 2's to help fit it all in. So we'll go -8 and then -6 and so on. It's important to make sure your intervals are equally spaced. So now k is trapped between -6 and 7, but we have to be careful. If you notice, the -6 is less than, so it's an open circle here, but it's a less than or equal to on 7, so it's a closed circle on 7. And again, it looks like a segment, so we close it. So k is trapped between these two. So this is how we solve an AND compound inequality. Notice all of our graphs look like segments.